Test. Test. Yeah, awesome. Welcome back from lunch, everyone. This morning, we already had a great presentation on CQL from Bryn Broads, and now we are continuing on that topic, and Wylem will talk us through leveraging CQL and CDS-hooks. The stage is all yours.
Okay. No, it's okay. Hello, everyone. So my name is Wylem. As for who I am, so I've been working on interoperability for a while now, a few years. I started in 2018. I worked with IHE on the Gazelle test platform. For those who don't know it, it's a set of test tools that allows implementers to then test systems on specifications. So I've worked with ICL 7v2, v3, CDA, and also Fire. And I happen to be recently Fire certified. So yeah, I'm bragging about it. And now I'm a tech leader at Firestain, where we do mostly consulting on Fire specifications and how to do to promote Fire. In this presentation, I will be discussing about CQL, CDS-hooks, and we will have a quick overview on how we can use those tools to build a clinical decision support system with a very basic example that we'll be showing you in the next slides. So by the end of this, by the end of this, you should have learned a bit more about what's CQL, CDS-hooks, and see through the example. So first things first, CQL. So CQL stands for Clinical Quality Language. It's a high-level authoring language that is aimed at mostly at clinician. It's focused on quality and producing computable and reusable clinical knowledge. And the idea is that you are creating clinical workflows and decision-making processes, and you're making them in an unambiguous and reusable way, because you have this uniform language. We worked, for example, on France. In France, we worked with FHF that had these really, really long documents, PDFs, or it was the idea was to lay down the criteria that makes someone at risk for diabetes, for example. And then you have those huge documents that are like PDFs with huge tables. You cannot really know how to read, and you have this problem where if you ask 3 different persons about what does this actually mean, they will most likely, all of them will give you a different answer. And this is what's nice about having this standardized language that allows you to have this computable clinical language that will prevent interpretation basically in the specification, and then you can also implement it way more easily and spread it more easily as well, as you can then, for example, put as we saw earlier as well, you can put those CQL libraries into your IGs. So for example, you could add everything that we will talk about later. We could have had an implementation guide where we put all these CQL files, etc. I will talk more about that later. So about the specification, so everything's available online. You have the link there if you ever want to go through the specification, if you want to learn everything about CQL. And if we take a look at the Ooh, that works. If you take a look here in the menus, you have two guides. One's named Authors Guides and one's named Developers Guide, and it does what it sounds like. It's like you have this language that is focused on clinicians. So the idea is that clinicians can easily lay down the logic that they want to implement, this clinical logic, in a computable and unambiguous way. And so there is this two levels on the specification, where the first level is author's guide, where you aim more at clinicians that want to lay down their logic and have it in this standardized way, where the developer's guide is more focused on more traditional developer profiles, like, for example, playing with Java, CQL, or C#, you name it. So, and obviously there is also a comprehensive specification on everything that CQL allows you to do on syntaxes and semantics and everything. So yeah, the specification is great, and I'll definitely encourage you to have a look.
We have a slight technical issue.
Yeah.
You need to reshare your presentation.
Oh, okay.
Sharing the wrong screen and the audience is not seeing that.
Oh, okay. Oh. This one?
Yeah.
Okay. Okay. Sorry about that. I was sharing the wrong screen. My bad. So I'll talk a bit about the CQL architecture. So we have kind of these three levels on the architecture. First one being the CQL language. So this will be more about clinician and human readable logic that will be provided by professionals, or at least people that are not full-on developers. And then below that, in a sense, you have the ELM, that is a more machine-friendly format that allows machine to actually perform what logic people wrote in their CQL libraries. And then below that, you can have basically any environment you want. So that you can have many different technologies. And what's great about that is that it kind of separates like the technology you use, your infrastructure, etc., from the actual source of logic, which will be then CQL. And then you can have whatever you want below it, so your logic stays the same, and then it's how you implement it that actually gonna change things. And that comes back to the fact that it is focused on clinicians defining logic, and then you have obviously this developing stack that you need to have in order to make things real on real data. That doesn't work. Okay, so I won't be presenting in many details what you can do in a CQL library. I think there are other presentations about that, even a Let's Build session on Friday, I think. But here is an example of really basic example of a CQL library and how does it look like. So first you have the definition of the library. You give it a name and a version, classic. Then you define the model that is used. So here we're using the Fire version 4. You can include other libraries For example, we included this library named Fire Helpers, but you can also use libraries that you defined yourself. So for example, you can define a set of logical functions that you want to reuse in many scenarios. Then you can just create a library that you can then include as dependency in all your scenarios. Then you can define terminologies. Here is simple value sets. You can also define codes. It's basically so that you have everything you need in the logic to select, for example, certain type of condition or observation or anything. This is a really basic example. So here we just have the female administrative sex, which is just one code actually. Then you define the context on which your library will run. So here is the context patient. So we are looking at patient, and then we define our definitions or expressions. Here it's really, again, basic example. Should have translated that jeune femme, a young woman. So that's really basic. Here the criteria is that a young woman is a patient that is a woman according to her gender, and that he's between 15 and 24. And so here it is. Here is a basic logical expression written in CQL. So what's also good about it is that you can see that it's declarative and functional. So basically, if I'm more of a clinician, I don't do code, I don't know how this will be implemented in real life, like where I will going to take the data, how I'm going to extract, for example, the gender. I don't know everything about that, but I do know what I need to be done in order to say, okay, this patient is a young woman. And so that's also why it's great for clinicians, because they don't have to know everything about the code and how it will work in real life to build up their logic. So again, invite you to go to the other CQL presentation if you want to learn more, especially the Let's Build presentation if you want to learn more of what is possible. Here is just a basic example. And lastly, about CQL, we have the Fire library resource that is used, that can be used to store the library. So as I said earlier, you can publish those libraries as part of an implementation guide. Here you see that we did it in this example a bit differently, because I cut it out because it's a bit long, it's base 64, but we directly put this text as base 64 inside the library. Why were we doing that? It's actually because in this setup we had not published the SQL libraries, but there were work in progress by the clinicians we were working with. We were editing actually the libraries, so we were editing these files, and then we could dynamically change them, and so we stored it as raw content in the library resource. So here it is for CQL, and now I'm going to talk more about CDS and CDS-hooks. So CDS stands for Clinical Decision Support. So a CDS system is basically a system or a tool that will provide help to healthcare practitioners to use data available in the medical record of the patient more efficiently and more accurately, because sometimes it can be really hard to crunch a lot of data for practitioners. and maybe sometimes it can take a long time, even though it's not that hard. But the idea is that the system will do the research work for them and then show them information or help to take certain decisions with more of an overview of the situation. So this is a meaningful use of the EHRs because obviously you can, the goal is to take this data and then apply a logic to it and then go back to giving information to the practitioner so he can take decisions. So yeah, how can this be applied? As said here, you can have drug prescription, diagnostic support, treatment planning. So basically, when a professional need to take a decision based on the medical record, you can have CDS systems to help with the decision. So here is a diagram about quality improvement system. So basically, what it is you do things, then you capitalize on it with data, then you analyze this data to have conclusions that you can then use to make life easier. So that's it. So basically, you have guidelines, then you can help people with professionals. Then you have measures on what happened. Then you can report it, research, and improve your guidelines. And this is a virtuous circle. And the aim is obviously having better services for patients and better healthcare in general. So there are two squares that are drawn on this to show where exactly you can use what we just talked about, like CDS is obviously going to be here. So for clinical decision support, and measurement analytics can also be related to the CQL we talked about earlier. But what we're going to focus on is this square here, where we are also going to be using CQL to help with the clinical decision support. So the benefit, as I said, you have easier decisions, hopefully, and the outcome for the patients and for the practitioner should be beneficial as well. Obviously, the costs are going to go down because if you automatize part of the logic, you can have faster decisions, etc., and you can improve processes. Increased adherence to clinical guidelines. Obviously, if you check every guideline, if you check those logics against the patient's data, you then it will then be easier to stick to it. A word about that is that it can be detrimental to the healthcare practitioner if not done correctly, because oftentimes those guidelines are huge. You have many logic to implement, and you have a lot of information that can be drawn from the patient's medical record. And if you go too far, you can drown practitioners in too many information, and they will just then you kind of kill the purpose of trying to gain time and have improving outcomes, because people are just going to be overwhelmed. So yeah, this still has to be done carefully. And improve patient safety, of course, if you implement clinical decision support, is to help the patient not to say, yeah, it's dangerous, but do it. So yeah, obviously, improve patient safety. So now about CDS-hooks. So what is it and how does it work? CDS-hooks is a hook-based API. It's based actually on the same technologies as Fire, which are HTTP, and JSON does not allow XML. I know you're all disappointed, but that's it. And there are actually three main principles or concepts on CDS-hooks that you need to know, and then you will have a good idea of what it does. So there is the services. So services is basically the system that provides information on a decision. So there will be the servers in the interaction. There is the client, which can be an EHR, can be another app, can be many things, but this is the system that will get triggered by the event and then send a request to the service to get information based on this particular hook or events. And then the service then replies, and the third big concept is called cards. Cards is what is going to get returned to the user after the hook. So you ask the service, okay, I got this event, this hook was called, was triggered, and then the service will return cards. What can cards do? Cards, there are actually three types of cards. There are basic informational cards. So the service just state that this is an information about your patient. In our example, we will use basic info cards just to say, okay, your patient has diabetes. So this is just an information, and then the system can, for example, display it to the practitioner as a pop-up or anything in the application. Then you have smart links. So links cards allows you to redirect the practitioner to another applications if more stuff needs to be done on this application. For example, if you, in this case, you could launch another application to do things according to the fact that your patient actually has diabetes. And third type of cards is what's called suggestions. And suggestions are basically, okay, we discovered, or we found out that the patient has diabetes. We suggest that, for example, you had a condition for diabetes into the file, the medical record of your patient, and then these cards can be acted on or ignored by the practitioner. But basically, the system, the CDS service says, okay, this is the actions that you may take according to what we found. And so, and the thing I want to talk about also is this this link right there, where actually you notice that the service can request information from the Fire server. There is actually 2.5 ways of giving information to the service. There is first information that would come with the hook that is invoked. For example, patient view will obviously give the patient ID, for example, of the patient viewed, and then this will automatically be transferred to the service. And you can also have what's called prefetch. Prefetch is basically the service saying, okay, I can be called on the patient view, but if you do call me, I need this or this or this information. So you have to prefetch information for me, and then you can just push those informations to me. But if you still do not have every information that you need with those prefetch and context information, you can still allow the CDS service to interrogate the file server itself. Obviously, when you are doing this, you need to ensure that the service does not have too much access to your data. So you have to restrain it for the user that is actually triggering the event. And this is done with a smart token that is forwarded to the service that will then connect to the file server using the same using the same credential, the rights, using the same rights as the user of the initial app. So yeah, basically you have an event that's triggered when I'm looking while you are on your clinician workflow. This event triggers a call to the service that look at data, can interrogate the server if he needs some more data, and then it will give you cards, either informations, suggestions about what actions to take, or a link to a smart app if it considers that you have actions to take, but it will be done on such applications. So once again, the specification is available online. So you'll have everything written down about CDS-hooks, and there is also, I included the link with to the cheat sheet because I find it really interesting and it's well summarized there what you can or can't do with your CDS-hooks. So now I will talk about building a support system using CQL and CDS-hooks for type 2 diabetes diagnosis. So as I said, it is really a simple example where we're just going to inform the user that we found out that the patient he's viewing has diabetes. So first you have to take the criteria that makes someone diabetic. So here are criteria that are provided by Haute Autorité de la Santé in France. So these are so yeah, blood glucose level superior, and so this is the logic as a clinician could tell us, like written with word. So we have to first kind of translate this. What does this translate to if we are using FHIR? So for example, the blood glucose level would be an observation with a certain code. Then you would have also the symptoms that could be a condition with value sets, including the different codes for the actual symptoms. And you can have also an observation for the third one. And I think this could also be an observation that was not highlighted, but basically you kind of, the first step is to translate those concepts into, okay, what FHIR resource will I use if I want to represent blood glucose level. So yeah, that's the first step. So here we have observation, condition, and another observation. So once we've done that, we actually kind of set up to use our CQL to create this logic in a computable manner. So we declare our library, so diabetes type 2 version. It was a beta version. So we are using Fire R4 as well, and we still use the Fire helpers library. Then what we need to do is declare all terminology that we need. So you will find Snowball link and the different codes and value sets that we talked about earlier. So this will be used to identify the observations that are found in the patient medical record, and so that you can extract it and apply your logic on those elements. The context will then be patients, because obviously you're going to want to have the patient and apply this logic to the record to know if the patient has diabetes or not. And then you can define rules. So this is just one rule, which is the second one. And so you see that you have the logic that here is exactly the same as the second point we viewed earlier, written down in English, but this time it's written down with CQL and it is computable for our system. So patient has diabetes symptoms. So you have this condition with the code included in the value set of all symptoms that we defined. And then you have an observation where the quantity is more than 2 gram per liter. And then you can define your final complex definition here, saying, as we saw, that it's either one of the three is sufficient to tell that the patient has diabetes. Then what we need to know is what we need to do is do some definitions that will then help for the CDS-hooks part. So we have this. So this is kind of repeat, but is diagnosis applicable? Then you have the diabetes condition that we saw earlier that combines the three criteria. And then we have those three definitions that will help us build the card. So we will have the name of the card. So this patient has type 2 diabetes, some details about the criteria that we found, and then the indicator that is an info. So now I will present to you the different requests and responses that we have for the CDS-hooks part of the systems. So there is this first interaction that's called discovery. If we want to make a comparison with Fire, this is kind of the capability statement. Is this kind of when you are asking the CDS service, what can you do? What services do you provide? And so you ask, you perform GET request on this URL, and you receive a list of services that will say, okay, I'm available on such hook, the title, description, ID, and here you can see the prefetch. So what data do I need to perform the logic? Here you can see we put patient, so we will have access to the patient, and observation with subject being the patient and the code that we wanted earlier. Here, as you can see, there is only one observation. We established that there were several observations as well as a condition that we were looking for. So this means basically that the service then still has to perform searches on the server to get the final information that it needs. Actually, this is to be, there is no actual kind of rule on that, but it's more about also performances. If you have to make a lot of calls inside the hook, it can be like slower and can kind of ruin the process. So you have to be careful on not putting too much information. So the call is not a lot of information sent to the services, but you also have to take into account that every information that we do not send to the service, he will have to retrieve itself. So then you can actually call the service. So you post on the service using the ID of the service that you discovered in the discovery, and then you have your hook, your instance. So the client can later track down which response corresponds to which hook, because many patients could be, for example, open at once. So you may not know which is one. And so as you see here, we also include the file server URL. That's because we did not send all the informations to the service. So he will have to use this server to get the final information that he needs. You have then the IDs that are the user ID, so the practitioner that was accessing the application, and the patient ID, which is the patient viewed. So these are context information. As I said, those are defined by the hook that is triggered. And so every service that's actually triggered on patient view will need this context to work. And then we have the prefetch. I blurred this part because it's actually the file resource that you are going to send for the patient and the observation that you found. And then you have the CDS-hooks response to that is a list of cards, as I said, and this is a very basic card, so a basic info card where you have the summary and the detail of the information that you found out on the patient working on the data. So this is basic info card. We maybe would have needed more information, but this is the basic example. And if you want to do more, I encourage you to see the specification, where you will see more about suggestions and links cards that basically not that different, but you have to actually give the link in the card, so it is just other attributes. And last part is how we used plan definition resources to link between the hook and the actual CQL, because what gave us information to put on the card, if you look at this information, it is what we defined earlier in the CDS library. So these information have to be taken from the return on the CDL execution. So first, we use the type. So we will use the type ECA rule. So decision support rule from on the form on even if condition then action. So basically, the plan definition says if you have a hook invoked, then you perform actions. And so we have the trigger on the action that is going to be, of course, a named event for our example, and it's going to be patient view. There is more to this that can be done. For example, you can also schedule, for example, executions, etc. You can perform many things. Here, we just decided to go for a simple event named condition. So here, what we did is that the CQL also enables the action, so the return of the card. So this is done by adding a condition of kind applicability, and then we use the CQL diagnosis applicable, and then we have these conditions on the three criteria that we described earlier. And if these criteria are met, then we can use what's called dynamic value, which is basically values that are not hard set on the instance of the resource, but will instead be taken from dynamic call to the library. So here we retrieve the summary, detail, and indicator. So this is the link. This is where I will actually get my CQL library to perform logic to get different parts of my card, and then this can be mapped to an actual card object that is as it is defined in the CDS-hooks. So what did you learn? Hopefully you did learn a bit on CQL CDS-hooks, a tiny bit on how to build a CQL library. Again, it was a really basic example on what you can do. And we've looked a bit more on what can be done also on the CDS-hooks API, and how to link your CQL with your fire model to enable your CDS-hooks to use CQL to get cards. Classic context slide. I'm here for 4 days, so do not hesitate to reach out to me. And I think it's time for Q&A.
Yes, thank you.
Thank you.
We have time for 1 or 2 questions. Any takers? Ewald.
Hey, thanks for the presentation. I was wondering, you're talking about and I was wondering whether, did you implement this, or did you, on which CDS server did you run this? Which technologies did you use, and so on?
We implemented something like was similar to this. That wasn't exactly this. We were using, it was more of a prescription-based system that was working on allergies and whether or not you should prescribe the medication to a patient with certain allergies. For the fire server, this was not our server, so we were just interrogating an external fire server with test data. The actual CDS-hooks implementation was custom, and we had open CDS Java libraries to run the CQL libraries that we were implementing. And as I said, the CQL libraries were actually written by us with alongside clinicians, so we can write this logic down. And so that's why also we had to put it, we decided to put it raw in the library content so we can edit it. So that was also a custom application where you could edit and then run on your tests and data your SQL libraries.
Okay, any other questions? If not, thank you so much, Will.
Thank you, everyone.
Enjoy your break.
Thank you.
Sorry for the hiccup with the sharing screen.
No, it's okay. I think, yeah, at first I cut the second screen because I had to look at my mails. Yeah, I know.